Hello and welcome. This is an update to the video. I took the video down to update this, and I'll put the video back up with this preface on it. First of all, let me apologize to my friends and viewers in Denmark and the Netherlands. Copenhagen is in Denmark. I had just finished watching a documentary on the Netherlands and had it on the brain when I made this video, and just it came out of my mouth and I never even caught the mistake. Copenhagen's in Denmark, so I don't mean to besmirch anybody, and I deeply apologize. It's just one of those Freudian slips, I guess. It just came out. At any rate, I now have the schematics for this unit. A friend of mine contacted me and said he had found some information, and in fact I will go get the link. I'll put the link up here somewhere where I found these schematics, or I won't put the link up, I'll just put a website up. And if you need these, they are available. I have downloaded them. There's hundreds of pages of documentation involved. This is not going to be an easy task, but we're going to give it a shot. I do, however, need some help out there from my viewers finding an extender card. This board has a pin spacing of 0.1 inches, 100 thousandths, which is, I believe, the norm for vintage equipment of this age. The length of the card needs to be a bare minimum of 6 inches or 15 centimeters. Longer would be better. 8 inches is preferred. I know there's a joke in there somewhere. The reason for that length is 6 inches will bring it just barely to the edge, but I'd have a problem working over here. So if I had an 8-inch length, an 8-inch length would bring the card out so that it's extended past the end of the frame. Now I could deal with it if it's 6 inches long, but you know, like I say, 8 inches or even longer would be better for working on this. Now I apologize again, I do not know how these are sized exactly. I've never been involved in the purchase of these extender cards. I've used them, but I don't know whether this is considered a 47 or a 46 millimeter tang. It measures 46.7 millimeters, 1.837 inches. And I'm sure there's people out there yelling at me right now oh, that's a 47 millimeter or a 48 millimeter. I don't know. That's why I'm throwing it out there. And if anybody has one of these at a reasonable price, let me know. I will gladly pay for it. I would be happy to pay for it. eBay doesn't have anything in the size that I need, and they are getting ludicrous money for them. They're anywhere from $37 to $47, and then they want $10 or $15 shipping on top of that. It doesn't cost nearly that much money to ship those things. It just drives me crazy, the money that people are asking for things these days. At any rate, I'll stop the rant. It's 18 pins per side, 36 total. That's the width of the tang. Minimum length 6 inches, 8 inches preferred would be absolutely wonderful. And again, I apologize to the folks, to the whole country of Denmark for my slip of the tongue. With that, we'll carry on. We'll put this video back up. We'll put this in front of it so you know I'm not throwing this away at this point in time. I'm going to give it a shot and see if I can repair it now that I have some documentation. That's it. Enjoy the video and thanks. Hello and welcome back. This is going to be a very short video, more along the lines of EEV blogs, teardowns. This was my main lab frequency distortion or audio distortion analyzer, And as I was setting up the main lab again down here, I turned this thing on to give it a checkout, and it's died. It has given up the ghost. And there is no way this is ever going to get fixed. Now, this replaced one of these in the background. Can you see the HP unit back there? This guy, that's the same one. That's the unit that was just up on the $10 test bench. I used to have two of these. I used to have one down here in the main lab, and I had a second one that was upstairs in the $10 test bench. And a couple of years ago, I acquired this, which is an automatic unit. It does all the tuning automatically. Not only that, it has its own built-in audio signal source from 20 hertz to 20 kilohertz. It gives you the signal to noise ratio, input output ratio. It was all automated. You basically just hooked it up, tell it to do a sweep, and it would sweep for you. It had an output on the back where you could interface it with a computer if you wanted to. Nice little unit. It's made in the Netherlands. This comes from a company by the name of Radiometer in Copenhagen. Built, I guess, around 1971, 1972. And as far as I can find on my research, this was one of the last pieces of equipment that they built before they stopped building RF type equipment and went into the medical industry and started making all kinds of blood analyzers and pH analyzers and all kinds of stuff used for the medical industry. That's kind of understandable. There's a lot of money to be made there. Probably a lot more than you can make trying to turn out test equipment. No schematics are available. The Radio Museum has a photograph of one of these. This is the BKF10. They have a photograph of it, and they have a note that they've been trying to acquire a schematic, but they evidently have had no luck. The oscillator still works. The interesting thing, the reason I thought I'd even do this teardown is the audio oscillator in this unit uses the same type of oscillator circuitry that's in the ICO that we just did a repair video on. This has the Wien Bridge oscillator. In fact, let me get this set up. Let me get the scope turned on and I'll show you. Okay, we've got it powered up, and if you watch the metering here, it just flops all over the place. Nothing is working correctly. In fact, occasionally the frequency meter will drift up and down and go from one end of the scale to the other. There is a metering board in here. Whether that's the problem or not is nearly impossible to tell. There's something like 14 boards, I think. Maybe it's 12 lined up. I'll show you when we take it apart. All plugged into a backplane. And they are just loaded with circuitry. There's something like, I think there's 3 or 4 automatic filtering boards that take the place of the tuning knob that's on the other Hewlett-Packard. It's all automated. Unless you have an extension card so that you can plug the cards in and do some tests on them, and the schematic to figure out where everything goes, it's virtually impossible to repair one of these. And I can't find any information on the thing, but the meters are just swinging all over the place. And if I switches there, you can see it just goes up to the end of the scale, and it'll eventually come back down. Nothing's working correctly. The LED indicators seem to work. It goes out of range. You'll see when the needles come down, it comes back into range. It says out of range here. It appears that a lot of the metering circuitry is working that's related to the over range and under range lights and where the meter is. Whether this is an input problem to the board from one of the filter boards, there's just no way of telling, because without documentation you can't even tell what the inputs and outputs are supposed to be. I actually had thrown this away and pulled it back out of the trash because I figured, what the heck, it's got a Wien Bridge oscillator in it, and I'll just show one more piece of gear that has that. The frequency meter was actually quite accurate, and in fact the output frequency knob is still in calibration. turned all the way counterclockwise, it's giving a 20 hertz output, and if I turn it completely clockwise, it gives a 20 kilohertz output. And if we look over here on the scope, we can see that. And I'll zoom in a little bit. Alrighty. Turn the... Come on. Oh, we're on the lowest range. That's what it is. There we go. Whoops. Now I've got to turn this back down. 5, 10, 20. Here we go. Okay. There, you can see that's the 20 hertz, and that brings it, see the bounce? Just like the ICO unit. Perfectly normal. Oh, it wasn't doing that yesterday. It's clipping. That's something new. It was not doing that yesterday. Interesting. I have looked at the power supply. There were a couple of capacitors that had gone. They were, you know, their ESR was about 15 ohms. I replaced them. My expectations were it wasn't going to do anything, and my expectations were met. I had zero success changing a couple of caps. Yeah, it was not clipping yesterday, so something else is going, it looks like. But you can see the bounce. There's another Wien bridge oscillator. If I put this all the way down to the lowest frequency, and we go over here and do a quick frequency check, we got 20 hertz on the money with the knob all the way counterclockwise, and if I turn it all the way clockwise and readjust these, there we are, 20 kilohertz. So that part of the circuitry is still working. By turning this frequency knob right here to maximum, it goes to 20 kilohertz, minimum 20 hertz. That functions. It also does an automated sweep. Right now it's on manual. If I go to single sweep, it will go to the highest frequency. That part of the circuitry is working, and I'll press the sweep button, and there it is sweeping down to 20 hertz. And it does it very slowly, of course, because all the filters internally would have to keep up with that to measure the distortion. They'd have to be able to notch that frequency out as it decreases and decreases and decreases, so that you would get a signal to noise reading. And eventually this will go all the way down to 20 hertz, and then when it does, it'll reset back to 20 kilohertz. And let's see, we'll let it go. It's dropping, dropping, dropping. Come on. It's got to be approaching the end by now. Oh, there it goes. It just reset. Back up to 20 kilohertz. So, sadly, this thing has... Yeah, see the metering here? Just now this one's pegged. Who knows? Like I say, I've looked quickly at the power supply without a schematic. There's not much I can do. It's nothing but a board with a handful of capacitors and some diodes on it. The whole thing inside is analog. but the complexity is just incredible. And I doubt even contacting the factory would get you any results, because 1972, they're not going to have any support for something like this. So let's power the thing down, shut the scope off, and we'll pop the cover and the back off of it and take a look at the inside. And just before I pop the covers off, quick look at the back. You've got the controller, recorder, looks like a DB25 here. I don't know what type of interface that would have taken. Probably something custom, no doubt. There's another output for distortion out. It probably comes out as an analog voltage, my guess is. Voltage selection switch, bunch of power transistors with heat sinks, and a fan. Nicely built unit. It's a shame that it died, but it is what it is. We'll get the covers pulled off. Okay, top and bottom covers are removed. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 PC boards. And there is a gaggle of trim pots. They are everywhere in here, all around the place. And this is just the top. It is the same on the bottom. If I swing this thing around, just row after row after row of trim pots. Without documentation, there's just no way you're going to figure this thing out. This could be as simple as one of these pots is dirty and needs to be, you know, just tweaked back and forth, but once you've done that, you've knocked it out of calibration. Without information, you know, without all the documentation, it's sadly done. Very nicely built. The potentiometers and the meters are all sealed up. The potentiometers are quality pots. It was a nice piece of equipment. What we'll do next here, now that the top and bottom cover are off, I can get to the screws here that hold this back panel on. This board, or this panel, is just the power transformer. Power transformer runs up to the front and is completely encased in a metal can for shielding purposes to make sure that there's no AC hum introduced. We'll get the screws out of the back panel and lift this off. And as Dave would say, for you patent aficionados, it's Danish patent number 127.893. It says down here, made in Denmark by Radiometer AS Copenhagen. Over here, serial numbers, that's in frame. It says type BKF10A, serial number 218120. Not that that information is going to be useful to anyone. We will get this board, or this panel, up out of the way. And this just carries the power transistors, the fan, and the power cabling comes back down from the power transistors to the power supply board here. Now somewhere, and I don't remember which one of these boards, there's 1, 2, 3, at least 4 filter boards. It looks like 4 filter boards. I believe these chokes or these coils are filter boards, if I remember correctly. I think one of these is the meter board. They're all marked. Yes, look at that. That's the frequency meter position number 7. Nice looking unit, and is just covered with all of these capacitors. And again, this problem might be this board. It's got some 7400 or 74 series ICs on there. Bunch of op amps on here. Who knows? Who knows? Some precision resistors, 10K, 37.6K. Whether or not the problem is in the metering board or in where it's getting its information, but you could, you know, it could take you the rest of your life to try to reverse engineer this thing. Oh, look at that. That fell right off that pot. Fell right off. Ta-da. That might be my problem right there. It might be that pot fell apart. That's something. No, those are intact. Huh, maybe I found the issue. You know what? I might stick a pot in there. I'll be damned. Yeah, there's no reason for that to fall apart. We have no idea where it was set, but we could set it in the center of the range and see what happens. Boy, that's funny. Yeah, that one's alright. That's nothing. Wow. Maybe it is the metering board. See, you guys help me out all the time. That's incredible. Alright, let me get that pot. Let me take that pot out of there, measure what the value is, and we'll see if we got a trim pot we can slip in there. Maybe we just fixed it. Well, that was a 100K pot, and I don't have a 100K pot that will fit in that hole pattern. We have no idea what that pot was set to, so I've taken two 50K resistors, which will emulate that pot being in the middle of its range. It'll be 50K on this side, 50K on this side of the wiper, where the wiper position would have been. And we'll solder that in, and we'll put the board in and see what happens. Now, even if this appears to work, it's still not going to be any good, because we have no idea what that pot calibrates. We have no idea what it was really set to, and I seriously doubt that it has anything to do with the waveform distortion. With the waveform distortion, this unit isn't going to give an accurate noise figure reading. But we'll just solder this in, and this is not a big Clive moment. I don't have his dexterity. There we go, those three are soldered. And as he said, we will crop the leads, as Big Clive would say. And we've cropped the leads and captured them so they didn't poke us in the eye. We'll slip this board back in and see what happens. Again, I have no expectations that this is going to fix anything. And again, I don't think I'll be disappointed in my expectations. But we shall see. And a slot on the top. No, I'm not. These boards are a very tight fit. Oh, now I came out of the bottom. It's a real pain in the tuchus here. Come on. Let's try not to break another pot in the process. Now all I did is slip the board out and set it down, and that piece of the pot fell off. So that pot is certainly, I'm sure, part of the problem, perhaps. Okay, let's I'm going to stick a screw in the back here just to hold the back into position so we don't have any Spitzenspaken. Stick one screw in the corner just to stand it up. What did I do with the power cord? It's over here. And what are the results? Oh, the frequency meter. Nope, that's input. I was going to say the frequency meter's working, but no, it just shot all the way upscale and came back. Nothing's changed. It's behaving exactly as it was before. Just frequency meter just went upscale. There's no response to the turning the knob, but just by putting on low pass filter it went up. Now it goes down. See, this makes me suspect it might be a filter board that's flaky. Which one? I haven't got a clue because we don't have a schematic to see which one is associated with that switch. And now it's not going back up again. No, it's staying all the way down against its hard stop. So my expectations were met. That's always good when your expectations are met. Ha! Ta-da! And no, it's not a dirty switch. That was one of the first things I did, is spray the switches just to make sure that it wasn't something really simple from sitting. I did pull all the boards, reseat them a couple of times. There's a multiple connection up here that plugs in. I took that out, sprayed it down. It's all gold contact, so that, you know, I had no expectation that was going to help. Gold doesn't really oxidize. This needle is supposed to follow this knob and give you a frequency readout, and it's dead. It's doing absolutely zip. So pull a couple more boards out of here to show you, and I'm going to wrap this up. Take this out, throw it in the junk pile for the recycling center, because there's certainly no way that this can get fixed. In 1972, it's not worth it. I could be here for months trying to figure out what was wrong with this. And again, I still wouldn't have any information on how to calibrate it. Let's, I think this is one of the filter boards. What does it say? It says band stop filter position number 5. Nice ground plane. Board number 900-457 for those playing along at home, as Dave would say. Could be anything. Could be more faulty pots. These pots are heavily oxidized. You know, who knows? There could be more of them ready to fall apart. Because all we did is take that board out and pop it on the table like that, and the wiper fell off of that pot. So. Is that straight? Nope. Went in the top one, missed the bottom one. There we go. What else have we got that might be interesting? I don't remember what this board was. Number 1 position. This is a pre-amplifier, position number 1, board 900-453. And again, how are you going to track any of this down? See the condition of those pots? I don't know if they're showing up well in the camera or not. Everything in here is heavily oxidized. No, none of these are falling apart. But who knows if they're making contact. You know, the oxidation may have gotten underneath the wiper section. And again, if you don't have the information on how to calibrate this thing, you're dead in the water. That was a preamp board. This is a log detector board. Got an op amp and a can here, another op amp and a can up here. This is an LM. This probably looks like a voltage regulator. Yep, that's a voltage regulator. So, nice looking piece of gear. It's a shame it died. But sadly, none of this stuff lasts forever. There isn't even much in here you can salvage. So this is destined for the recycling center. Somebody will probably scarf all the aluminum off of it. If it was a piece of Hewlett-Packard gear, early Hewlett-Packard gear, it'd be worth a lot of money because it'd be a lot of gold on the boards, but not the case here. It doesn't have a lot of gold. What do we got here? Another band stop filter, position 3. So it looks like there's 3 band stop filters. No, I think that's a band stop. I think there's 5 of these things. Are these band stop filters as well? They are. There's a whole row of them here. So we got 1, 2, 3, 4, 5. What's this guy? That's a phase detector. So we got 5 band stop filters, which would have been automatically tuned as you dial in the frequency on the knob. Say if I dialed it into 200 hertz, it would set all of these filters for 200 hertz to notch out the fundamentals so that they could measure the distortion. And how all of that is tied together internally on the back plane, or what's controlling these versus that frequency control, nobody knows. It would be a hopeless task to try to make this thing work unless you had full documentation. And that's unavailable. So I guess that's it. I'm going to button this up, throw it in the back of the truck. Next time I'm up to the recycling center, we'll drop it off. Mildly interesting, perhaps? Let's hope so. I'm the radio mechanic. Sad day on the bench. Talk to you guys later. Bye.